Okay, so now we're going to go ahead and solve an equation involving fractions. And this would be a lot easier if there weren't fractions in the problem, so let's get rid of the fractions. In order to do that, the basic idea is find the LCD, multiply both sides of the equation by the LCD, and your fractions will magically disappear. So let's do it. So normally to find your LCD, you got to factor the denominators first, but these denominators are already factored, so we can look at them and see that we're going to have that as our LCD. So then, I'm going to go ahead and rewrite the problem here. I'm going to multiply both sides by the LCD. So remember that this LCD is going to multiply by both sides entirely. On the right-hand side, it's going to distribute to both of these terms. So I'm going to have 2 over x times x minus 2. And then I'm going to have 3 over x minus 2 times x minus 2. And then I'm going to have 1 times x minus 2. So that LCD gets multiplied by all terms of the equation. Now I can start canceling. The first fraction, the x's cancel, and I'm just left with 2x minus 2. The second fraction, the x minus 2's cancel, and I'm left with 3 times x. The next one, nothing cancels, so I just have minus x minus 2, and now it's much more straightforward. No more fractions. I'm just going to distribute and see what kind of equation I got. So if I distribute the 2 and distribute the negative x, whoops, I get this. It's a quadratic. So I'm going to make one side equal 0 and see if it factors. I like to factor using a positive x squared, so I'm going to move everything over to the left-hand side. I'm going to make the right-hand side equal 0. So I'm going to add x squared to both sides, and then I'm going to subtract. Well, let's see, on the right-hand side, I actually have 3x and 2x. That's 5x. So I'm going to subtract 5x from both sides. I got negative 3x and minus 4. And this one, sure enough, will factor into x minus 4. X plus 1, set each factor equal to 0. And I get x equals 4 and negative 1. Now, you do need to check for extraneous solutions with these. Let me move this down a little bit. So we do have to make sure that none of the denominators become 0. And so what you do have to check is just go back, look at your original denominators. In fact, your original denominators are contained in your LCD. So you actually can just look back at your LCD and make sure that none of your solutions will make the denominator equal 0. And they don't. So they're keepers. Let's make a note of that. Make sure, I'm going to move this up, that no answer makes any denominator equal 0. So the nice thing is checking for extraneous solutions on these is not too bad. You don't have to go back and plug it in the original equation. Just double check the denominators. It's a little mental check, and you're good.